Welcome to the Scaffold Stellar tutorial. The Scaffold Stellar project comes with some starter contracts, two of which are from OpenZeppelin's example contracts, so some pre-audited contracts for you to use, one NFT and one fungible token. And you can use those contracts, but we also have a contract in there that we'd like to explain and use in this tutorial to show you a little bit more about writing smart contracts, about using smart contracts in your Web 2 projects, and being able to interact with the Stellar environment, Stellar blockchain, Stellar CLIs, all of the Stellar tooling that you get that make it easy to develop around Stellar. So before we get going, we're going to split this tutorial into two parts. The first part is going to focus on getting started. And when we do that, we're going to go all the way from prerequisites to walking through the files that you have in your environment when you have a Scaffold Stellar project and what they mean, and walking through that starter smart contract code. In the second part of the tutorial, we will go through that same smart contract that we went over in part one, and we'll make some improvements to it and continue to evolve the contract. Some of the prerequisites that I need to make sure I have Rust. So I have Rust C version. I have a Rust compiler on my machine, and I need to make sure I have the Stellar CLI. So I've got that. I've got npm. I've got Node. And to install these prerequisites, they're generally the same as the Stellar CLI, and you can use the docs for the Stellar CLI for installing these prerequisites and getting the Stellar CLI installed because you'll need it. And I need Docker. And so I've got my prerequisites all set. Once I have those, I can cargo install Stellar Scaffold CLI. But I'd actually recommend that you use binstall. So cargo binstall is a tool that lets you install binaries. We at the AHA Co, the maintainers of Scaffold Stellar, we ship binaries of the Scaffold Stellar CLI and Scaffold Registry CLI, Stellar Registry CLI. And those binaries are much faster to download and much less error prone in terms of having various issues on your machine or your environment. Just downloading binary is going to be a lot faster and going to work more consistently. So I'll binstall, which it looks, I already have the latest version. So I already have the Stellar Scaffold CLI, and the crate is named. So crate is being the package in cargo, which is the build tool for Rust projects. That name Stellar Scaffold CLI, even though we call it Scaffold Stellar, calling it Stellar Scaffold CLI as a package allows us to reference Scaffold Stellar as a plugin of the Stellar CLI. So you'll see me run Stellar Scaffold in order to interact with Scaffold Stellar. So in doing that, I'm going to go ahead and start a new Scaffold Stellar project. And I'm going to do that with Scaffold Stellar Scaffold init demo. And that's going to create a new project demo. I'm going to go ahead and npm install in this folder. That's going to run for a minute. And then while that's running, I'm going to open the code editor and walk through some of the files that we see in this environment. So at the top level, we've got the things we expect to see from a web project. So this project in your front end is a Vite and React project. So Vite being a build tool. And so because of that, we have our package JSON, which, because we're basing on the Scaffold Stellar front end template. And in the future, we are interested in supporting other frameworks other than React. If you have an interest in that and want to work with us, all of this code is open source. We're really interested in collaborators. And if you're interested in it, the best way to get something on the roadmap to come sooner is to let us know and express your enthusiasm and interest for it. And even better if you want to help. So at the top layer, I'm going to talk about, we have our cargo toml is the Rust related manifest that tells us what we have in our, how we describe our project. cargo lock is the lock file for, you're not going to edit that. That's manually, that's machine generated. So cargo, the package manager, manages that. Our contracts directory up here is, we've got the smart contracts that we have from Fungible Token Interface and NFT Enumerable are Open Zeppelin audited contracts. And then guess the number is the contract that we're going to walk through and we'll edit in part 2 of this tutorial. So this contract, so let me go ahead and open that file. And so this is the guess the number contract. When we are interacting between our smart contracts and our front-end web application, and also other build settings, the file we're going to edit and use is the environments.toml file. So this file defines different environments. So in this, we have development, staging, and production defined. And we define different characteristics for it. So in development, I'm going to use my local running Stellar network so that I don't have to be connected to the testnet environment in order to use it, or mainnet. And I can define accounts, and Scaffold Stellar is going to create those accounts and create those identities for me. It's going to create clients for the contracts that I ask it to. So I say, please create clients for these contracts. And when you construct that, when you deploy and call the constructor for that contract, these are the arguments I want to pass. We'll go over this more in depth when we look at the smart contract code of what that constructor means. And so those are the Open Zeppelin contracts. And then our guess the number contract that we'll walk through. We have lots of comments in the environments.toml file to help you understand what's going on, and constructor args, as we talked about. Finally, the other file at the top level we wanted to show you is the Rust toolchain, where we define the channel, so what version of Rust I'm using, the targets, WASM32 v1 none. That is also a dependency that you'll need to have. So a Rust target in order to compile the smart contract WASM. So at this point, our npm install is definitely done. And I'm going to copy my env.example to env. And then I'm going to run npm start. And that's going to do 2 things concurrently. It will run Stellar Scaffold Watch build clients, which is a program that will build the bindings and packages that allow us to then call our smart contract code from web code, so we can interact with that. And it's also then it's calling Vite, which is our web build tool. So building the React environment and getting that set up. So that needs to first, because on the homepage of our app, we do depend on the guess the number contract, we're going to let that compile, and that'll keep running for a minute, and then I'll show the front end. But now let's go ahead and start with reading through our contract code. I said I'd talk about the constructor. So when you deploy and instantiate the contract, which we'll end up seeing happen already over here. So we are deploying, and we've now gotten to, we should be getting to guess a number. There we go. So guess a number, build, and a lot happens in this output. All right, so guess a number. I've already been messing with this contract so that WASM was already installed on my local chain, and it's deploying that contract. There's the contract ID. In my environments.toml, I had an after deploy script, so it's executing that script that I asked it to. And then it is creating the TypeScript bindings, and where those end up is in this package folder. So these are the TypeScript bindings. So think of like an npm package, but for your smart contract. And then I'm able to use that in a contract. So in the React code, there's these contracts that bind to that library over in packages and create clients. So then I can use it in the component. And so if I were to look at this front end, give it a second to build, run, and it's asking me to connect because I previously connected. Let me go ahead and ignore that and see if, yes. So it's prompting me because I've interacted with it before. And so you would see a connect button, and then I would choose to connect with Fighter. I'm going to go ahead and connect with my local environment. And in order to connect with your local environment, Fighter by default does not have local environment settings. So in order to do that, let me show you where you do that. In Settings, Network, Add Custom Network, you'll have this form. And the settings that you'll want for local are right here. So you can take a screenshot, pause the video. This is the configuration that you'll want to set. You'll want to check the box if you're doing local development to connect to non-HTTPS networks, because I'm working locally, so I don't need to worry about HTTPS. And that is how I can connect locally. And so now I can I'm interacting with, it apparently was one. So I'm interacting with that guess the number contract. And so that contract is deployed, and that was all done by the Scaffold Stellar tooling. And so it's actually Stellar contract invoke guess the number. Scaffold Stellar also I need to set my keys, use me, Stellar network, use local, and now I'm ready to interact with this on my local network. So I can, let's say, since I deployed it, I want to reset the game. And since I'm using my me key that is the admin, then I reset it. And so now I should be able to guess one, and it reset the game. So it is no longer one. And all right, back to the code of the smart contract. So when the contract is deployed, we set the admin, and that's happening in this constructor. So constructor args admin me. And we might want to pass other arguments to the constructor. The OpenZeppelin contracts had some other arguments. As this contract evolves, we'll want to add other arguments as well. In order to have an admin situation and be able to require auth, I have a few private functions where I am getting the admin out of storage. I'm storing it in this admin key, which I'm using symbol short in order to make sure that storage is as small as it can be in terms of storing that address. Setting admin only gets called in the constructor. So this is on purpose, not meant to be publicly callable. It doesn't have a pub in front of it, so it's not exposed in that contract API over here. So you see that there's no set admin over here, so that is not publicly exposed. And the require admin gets the admin out of the storage and calls require auth, which is our function that ensures this address has the authorization that we are requesting. And other functions that we have in our API, we have the reset function, which requires the admin, and it changes the number to a new random number between 1 to 10, sets that number in the contract. You'll also notice that, so let's talk about imports a little bit. So we don't include the Rust standard library. Part of that is that we're compiling down to our WASM, and we want that to be as small as possible. So we only want to explicitly include what we want to explicitly include. So we're explicitly including some various parts of the Sorabound SDK, which is the Stellar Smart Contract SDK. And so we have some macros for contract and contract implementation. So those are where we define how we're implementing our contract. Two more functions to cover is we have guess. So guess is the function where we are comparing the number that's passed to the guess to our storage and seeing are those matching, and then we're just returning that value. The upgrade function allows the contract WASM to be upgraded. If you have a public function in your contract API called upgrade, Scaffold Stellar is going to call it when it's expecting to update the WASM so that you can use your upgrade functionality rather than constantly deploying and having new contract addresses. So here for upgrade, I require the admin and I call the update current contract WASM function with a new WASM hash that if I'm calling upgrade, Scaffold Stellar will handle this for you. And now that's the first part of a tutorial, and we've walked through the guest and number contract. Hello, welcome to part 2 of our Scaffold Stellar tutorial, where we're going to make some improvements to the guest and number contract. So currently, we have our contract configured where we set the min and the constructor, and then the after deploy is when we are calling reset. That's not the best way to do this because there is, in theory, a gap between when the contract is instantiated and when it has a value in the game. So let's instead make sure that setting the number happens in the constructor. I'm going to create a private function called set random number. And we're going to take our environment, because we want to interact with it. And what this actually I'm going to do is this the same code that's up here in reset, and I'm just going to copy it, paste it down here, move it around. I'm going to make sure that I update and call set random number up here. And now I can add that call to the constructor as well. Let's go ahead and get that formatted nicely. And you see that my environment sees and is updating my code. And it's going to run update on that contract WASM. The other thing we're going to do to improve this function is we'll improve the error handling. In the guest function, we call unwrap, which mostly works, except let's replace that unwrap with expect, because then if we unwrap the value, then there will be an error instead with a custom message rather than a mysterious crash. Great. So now we've improved the error message. Let's look at the guess the number front end code a little bit to see how we're interacting between the smart contract and with our environment. We imported our import game from that contract library. And in this form, we submit guess. So when this form is submitted, so either the submit button, the form action is submit the guess, and the guess is await game.guess. So our game has that. If we looked at game, we've got reset, upgrade. We won't want to call those from the front end, but just to show you that that public API is visible in your JavaScript bindings. And so we're passing that guess to the game, getting the result back, and then setting the storage in this small guess the number component so that we can display the success or not. Ways I'd recommend going forward from where we are here in the tutorial is right now the game is an open, like other than having an admin, it's an open game where there's no economic incentive, there's no associated winners, things like that. What I suggest is adding to the guess function and add guesser, and then you can add a authentication around making sure. So I'm saying this account is making this guess, signing that, and then you could wager into that guess and put money into a pot. And so then we get into token transfers and then managing state in the contract. So that's what I would look forward to next in how I would expand this contract beyond what it is now, is adding some economic incentives, adding transactions, looking at authentication beyond just the admin, and that's how I would move forward as you explore this contract and look at where you can change it and upgrade it for your own purposes.